my slide is visible. Anytime, at any point, if any slides are not changing or code window is not visible or slide window is not visible, you can please interrupt me in between. Interruption is not a problem. So what we'll do is today we'll cover basics of IoT, what is IoT, its applications, and some demo we'll do live on the hardware and on software side. It's a simple thing, not too much of software is involved, especially in the website. Maybe in Arduino side little software is involved, but we'll go through complete software. Okay, so today's presentation is divided into various parts. So sometime we'll give to a theory of IoT, which contains of application and introduction, and then we'll talk about various IoT hardware and software. Then very famous hardware is ESP8266 Node MCU. We'll go in depth of that. We'll understand what that chip is, how it can be useful for our projects, and then we'll try to log in into ThinkSpeak website, send data manually using web browser like Firefox or Chrome or Internet Explorer, whatever browser you are having. We'll make a website all together. First I will send data, you also send data to my website, and we'll see how this data building is happening. And then later on what we'll do is you also create your own and share the link. Then instead of sending manually with the web browser, we'll try to send with 80 commands with proper coding in hardware, and then we'll integrate everything into Arduino sensor and everything and send data automatically. So that will be our outline of today's thing. Okay. So when we talk about IoT, people think it is a future technology. Okay, it's not like that. Currently, many industries are using IoT in day-to-day life, and IoT is not anymore a future. It is a very big industry, $1 trillion industry. Okay, and it's top 10 technologies of the world, which is in the buzzword. So if you see what is buzzing, like cloud computing was buzzing 2 years back. Now IoT is there, nanotechnology was there. So like that, few buzzing technologies are there. So IoT is one of that buzzing technology. Just search on naukri.com or any job sites. You will get thousands of jobs available for IoT only. Worldwide, more than 50,000 jobs, and this is old slide. So maybe by now 1 lakh jobs may be there. Okay, and there's a huge IoT requirement now because of pandemic. People don't want to rely on humans. They want everything should be automatic. Everything should be, data should be available on their phones or on their apps. So IoT intervention in the companies, or IoT probing and IoT infusion in the companies have increased so much. Okay. So when you talk about IoT, what is IoT? Okay. So basically it is networking. It is networking of physical objects. So what kind of physical objects? It can be buildings, it can be vehicles, it can be industry, it can be sensors. All these are connected to each other and they talk to each other, and data is connected to a server, and server will analyze and process data, and based on that it may take some decision or alerts or some control. So all this data exchange between the objects is basically IoT. In short, IoT makes your items more intelligent. The things start thinking. Things means your, for example, your toaster or your washing machine, your fridge. If you talk about home, if you talk about industry, your lathe machine, your CNC machine, they started thinking. They start talking. That is the meaning of IoT. 3 A's of IoT, which I always teach to my students, and I always tell them, please don't forget what are the importance of IoT, why it is so important, why it is so happening, why it is so much popular. So the IoT gives power to you or industry, power of 3 A's. Anytime, any place, anything, and also nowadays you can say anywhere. Okay. Now anytime you want to see any patient data, you don't have to go only 9 to 5. Anytime, night 3 o'clock also you can see the patient's data. Okay, if you are moving, if you are in Delhi, you are Mumbai, you can see the data on the move also. So no restriction on data access, any place. Okay, so again, any place and anywhere means too, your sensor may be inside the house or outside the house. Your sensor you might have put in vegetable fields or gardens, or maybe in some desert. It will give the data output. Only thing is it should have connectivity. And anything means I can connect IoT to human also. I can connect IoT to a robot also. I can connect IoT to a machine also. So it may be a human to human connection, human to thing connection, and machine to machine connection. Also IoT, or also that's why called machine to machine communication, M2M. So if you see the IoT, IoT is the current technology today's word, but before that also many different companies have coined different terms, like GE has coined industrial internet, Cisco has coined internet of everything, Claro Partners has coined internet of everything, web of things, industrial IoT, embedded internet. So all this finally meaning is this machine to machine communication is happening, and they make your things to think and talk, also called ubiquitous computing, everywhere computing at any place, everywhere. So as I was talking about history, the internet of everything, world size web, machine to machine communication, all these are you might have heard somewhere in some magazines. But Skynet, Terminator movie, that also is one type of IoT only, because all these robots will talk to each other to the main hub, main hive, main brain, which is Skynet. So in 1999, Kevin Ashton, so this is a buzzword, this is a kind of 𝐭𝐿 𝐁𝐫𝐿𝐿𝐿𝐿𝐿 question, ABC. Okay, that Kevin Ashton was the first person to introduce the name of IoT in 1999. Okay, so IoT was before 1999 also, before Kevin Ashton also, it was there. There was an internet conference in which somebody has demonstrated IP enabled toaster. Okay, in 1970s, using phone line meter readings were taken. Now we are thinking automatic meter readings by Bluetooth or wireless or Zigbee or LoRa. But in 1970s itself, many people have automated the meter readings, the energy meter readings via grid, via electrical grid, via telephone. So no need to go and note down the numbers. Even in some colleges and some universities, they have demonstrated different IoT concepts like coffee pots and soda machines. So if you see the statistics, so currently only 1 to 2% of the things are connected to each other. Now you imagine refrigerator, car, washing machine, if they are able to talk to each other, then what will happen? If outside temperature is 25 degree, automatically AC will set to 24 degree and 26 degree, so that your bill is less. Washing machine, the clothes you have kept, okay, it is detecting that the detergent what you are using is not so good or it's bad, and it may tell, okay, as per this cloth, this detergent is not good. You are putting a woolen cloth, you should put soft detergent. You are putting jeans kind of cloth, the detergent is different. So, and he's having the access to your shelf also, and in shelf it is saying this detergent is over, it may order from Amazon automatically. Same way with refrigerator, you have butter cabin, you have eggs. If eggs are over, automatically Amazon it is putting into cart. So all those things are possible if things are able to talk to each other. Then, as I told you again before also, that the market size, the budget, the revenue from the IoT is in trillions and billions of dollars. So if you see the data generation by sensors, it is increasing exponentially. 90% of the world data, which you can see in Google Cloud and Amazon Cloud and various clouds, and your Instagram, Facebook, whatever data is collected now, YouTube also data, a lot of data is uploaded by YouTubers. 90% of data is collected in last 2 years only. So before that much data was not there. Now we are talking about petabyte, exabyte, hexabyte. See, in India, there is a body called NESCOM, and it keeps on doing survey and regulatory body also. Okay. In India itself, it is a $15 billion market. $1 billion is 7,000 crore rupees. So you can imagine that much big market is there. So digitization of the agriculture, education, financial service, health, machineries, all those things are going to add the economic value. See, you are going to make the process efficient. Once you make the process efficient, it is good for nation only. There is no wastage of electricity, no wastage of any resources, no wastage of raw materials. So that way, by helping the system to become more digitized, lot of wastage can be avoided, and this kind of thing will be done only with the help of IoT. Even in last 5 years, if you see, 70% of companies have come with IoT concepts only. So when coming to your architecture of the IoT, you can see here, we are able to see 4 layers. So first layer is the sensor connectivity layer. All the sensors and nodes will be at the bottom layer. Now this sensor doesn't have internet. They cannot send, they don't have networking capability. So you need some kind of networking hardware, a gateway or a network hardware, which can be used. It can be Wi-Fi, it can be Ethernet, it can be a simple LAN or RF transmitter receiver. So using that, data will be sent. Okay. Once data comes to a cloud, a management service, there only all your data will be stored, and based on the application, your data will be processed, and based on that, based on the application, the process data will be useful in environment, people tracking, healthcare, retail, supply chain, surveillance, everywhere this kind of thing can be used. So application layer only, your final data processing and control is happening. Management service is nothing but data storing and your security, all things. Gateways are your connectivity, and sensors and networks are your low level things. Okay, because sometimes what will happen, suppose I am having a sandalwood park. Okay, in that 100 sandalwood trees are there. So each and every tree I cannot put gateway, internet, Wi-Fi. So what I'll do, all these 100 trees, only in one tree, in the central tree, I'll make a GSM modem and Wi-Fi, all this capability. Now all these 99 other trees will become nodes. They will get the data of vibration and sound and other things and send to the main hub. Now this hub only will have gateway, and that will send to the internet. So like this only people are managing. Nobody will have a separate sensor having Wi-Fi or gateway technology. So IoT in simple is business process optimization and digital upgrading. If you want to digitize your company, your process, your college, your home, anything, you might have seen nowadays Alexa and IoT bulbs are coming very cheap. You can use them. Alexa control plugs are there. IoT control bulbs are there. So what is that? That is nothing but digital upgrading. Second thing is remote monitoring. So from sitting at home, sitting in office, I can see my park, I can see my fields, I can see my vegetation, my agricultural sites, my industrial sites, my machinery, how they are behaving. So this remote data collection and update is very important, which is possible with the help of IoT. So basically, if you want to process business process optimization, you want to do, you want to optimize, and you want to make your business process more efficient, your supply chain or your manufacturing chain or your security chain, anything, if you want to make it more optimized, more efficient, you have to use a technology which somehow involves internet. So these are the various applications when we talk about IoT. So smart cities, if you are going, this street light should be controlled based on a traffic density. Street light should be controlled based on day of time. Street light should be controlled based on holiday or non-holiday. Street light should be not street light, the traffic lights. So all these bases should be done to make a smart city. Street light also up to 10 o'clock all lights on, up to 12 o'clock maybe all lights on. Then after 12 o'clock alternate lights can be made on, and whenever vehicle passes, then only all lights become on. So all these things should happen. And remote monitoring should happen. Which bulb is working, which bulb is not working. Any bulb is not working, the control system will come to know. They will come and replace the bulb. All those things should be done with the help of IoT and to make a city smarter. You have a garbage collection technology. If garbage bins are 80% full, send an alert and get it collected to that GPS location. Smart environment. You keep on putting pollution sensors all over the city. Monitor which traffic junctions more gases are there, more harmful. Then you can send the police and check any vehicles are not emitting harmful gases, whether their PUC or pollution check is health check is okay or not. Smart energy, as we have seen how this meters can work, how electricity can be like optimized by street light, and how this transmission of the electricity can happen. Like people will reach home around 7 o'clock. That time they'll go home and make on the microwave. Till that residential area doesn't require much power, but industrial area, afternoon more people are there, more ACs are working, that area requires more power. So all this measurement can happen automatically, and machine learning codes can be there to understand where requirement is when and when more load should be given to that area. Then smart agriculture, you come to smart agriculture, crop health protection. Okay, how much water should be given? What is the prediction from the weather? Today it will rain or not? See, it is going to rain within 2 hours. Then why you want to put water? It will come automatically from the clouds. So all those things can happen in smart agriculture. Then e-health, a patient can be discharged. No need to keep patient at hospital only for monitoring purpose. He can simply go home and doctors can monitor him from remotely. And many other applications in health possible. Retail, see, when you go to shopping mall or you want to go Big Bazaar or Reliance Smart, many things can be tracked, how customers are behaving, which things they want more, where they stand more. All this data can be collected, and automatically things can be such a way they can build that you don't have to go to supermarket much and much. Less queue for billing will happen because automatic billing will happen. Once you keep taking things and put in trolley, automatically it will get into the billing there only. Once you go out, just pay via Paytm or Google Pay, and then just no need for standing in queues in retail stores. Logistic is like if you have fleets of truck like Gati, Blue Dart, and you are sending couriers here and there, all this can be monitored with the help of IoT. And industrial control, when it comes, all we know, all industries have a lot of parameters to be monitored, from voltage, currents to pressure and temperatures. All that can be controlled and monitored via IoT devices all over the company, all over the manufacturing site. So what I mean to tell via this slide is the IoT applications are seamless and they're everywhere. It is a ubiquitous technology which can find application in every domain of your life. So that only I was explaining just now, that IoT in healthcare, patient can be left, and suppose this old man is walking in a park and suddenly he gets some kind of health problem and he falls down. The fall detection sensors are there, and automatically GPS location will be sent to family and doctors, and immediately ambulance will come and family person also can come. So healthcare is the biggest market in IoT, and I like this field very much. So I'm going a little deep in this. Just want to tell you, there's so many companies are there. They work on different parts of your health. For example, if you see the leftmost top, clinical efficiency, then clinical grade biometric sensor, then clinical and home monitoring, brain sensor, fitness variable, like what you may have Fitbit, you might have seen this MI bands. All these are what? They are again one kind of IoT devices only. And then sleep monitoring, infant monitoring, all these companies, a group of companies are working towards making your health, your IoT into the field of healthcare. Now at home, just I was giving an example, like your fridge can order eggs for you, butter for you, buy milk for you, or you can remind you, or you can directly put things into the shopping cart. So IoT at home, from energy saving to automatic shopping cart building to security, all things can be put into one umbrella under IoT at home. So these are the various IoT platforms. Out of all this IBM, Microsoft Azure, and Amazon Web Services, these three are very famous and they are very much used. If you get time, please go through this Amazon Web Services or Microsoft Azure or IBM Watson, all these technologies and all these frameworks and all this platform what they are giving. So we are going to use one platform which is free of cost, and that is from the MathWorks company, which is the same company which has devised the MATLAB, which is a developer of the MATLAB. The company name is MathWorks and the platform name is ThinkSpeak. So your things are speaking to you. So that way we are going to use this platform, ThinkSpeak platform. Why we are using this? It is very easy to set up. It has many features, like it can tweet. It has interface to tweet. It has very much nice interface to MATLAB, so you can do much bigger processing with the MATLAB in hand. Okay, and it is very good for experimenting. Lakhs of users have used this, and it provides very instant widgets for visualization data in graph form and maybe in sensor form. Gauge form and red LED, green LED kind of form. Okay, so what is ThinkSpeak in short? It is basically a IoT analytics platform which allows you to collect, aggregate the data, visualize the data, also analyze data with the help of MATLAB. So you can send this data to ThinkSpeak via any kind of devices which is connected to internet. Maybe it is a hardware like ESP8266, Arduino kind of hardware, Raspberry Pi kind of hardware. Even you can send from your phone, even you can send from your desktop or laptop PCs. Okay. But when I talk so much of IoT, you can see so many slides I have discussed, but I have not discussed any bad thing, correct? The bad thing is, are you safe and secure? So when you connect everything to internet, anybody can hack into your fridge and they can find out about you. Suppose you are eating a lot of butter and he sees that, okay, this person every weekly half kg butter he is eating, then maybe after 6 months this fellow will have a nice cholesterol. Okay, so what we'll do is insurance premium will increase for him, because anyway this person will die soon, or maybe he required medical insurance soon, so we should not give him in less cost. Otherwise, in some people who are very healthy, eating only broccoli and green vegetables and all like this, if I'm able to understand this kind of things he's eating more, then medical insurance people can give more discount to him, more coupons to him, so that he can also buy. Otherwise, if he don't, these kind of people are more good for them, the person who are healthy. Because insurance company, if 100 people are taking insurance, only one is claiming, then insurance people are happy. If 100 are taking and 50 are claiming, then insurance companies will get bankrupt. So they are just playing a gamble on us and on our health, and with more and more data, they can do it more better. So are you safe and secure? If you are having very default and very weak passwords, okay, or you cannot change the password if it is hard coded in the code, then your security is compromised. Okay, if you are not able to upgrade your firmware, if you are not able to upgrade suppose you have made some devices for any patient and you are not able to change the code of device if any errors are there, then problem for you, correct? Then again patient has to go to the seller or vendor, give him the old device, wait for 1 week, and then upgraded device will be given back after code update. So that kind of things is very difficult in IoT world. Okay, and different people are making different devices. So many companies I've shown you, this many platform and this many companies. Suppose for example you are taken from something from Arora, okay, and if sensor goes bad, again you have to find that company, same company only, to get it repaired. Then various type of hacking attack like spoofing, phishing are easily possible if you have a simple design. Coding error, see person like me and person like you are writing the code and nobody is verifying the code, nobody's software testing is not done, then it may happen that coding error will go into the final product. Okay, and clear text protocol, what is meaning of this? We'll be using in our demo today. So this clear text protocol I will be using, and we'll see that how easy it is to hack into the cloud and send and read data if you are using clear text protocol. Then denial of service attack and DOS attack. So this kind of attacks are again hackers will use to bring the server down. So it is not able to steal data, but it can stop the server. So connectivity will stop and the server will be what we call crash. So this is happening with the DOS attack. Physical theft and tampering. That means suppose I have put into my vegetable fields and my agriculture fields and my garden some IoT based devices. Somebody can simply take that and run away, and they can tamper. Why they want to tamper is they want to understand my Wi-Fi gateway username and password. If my credentials are hard coded, they can tamper it, and they can from there they can connect some hardware and try to find out at what Wi-Fi username and password is trying to connect, and they can get my data. So anyway, today's practical will see how this simple things, if you are keeping too simple, it may lead into safe and security problem with IoT devices. Okay, so we'll end this theory part here. Okay, let us go to a presentation on how this hardware of the IoT looks like and how it works. Okay, so there are many type of different hardware available. One is like this, which I'm showing now. This is Node MCU. It is advanced version of ESP8266. Okay, I'll show you ESP8266 also. Yeah, I have. So this small one is ESP8266. So now you can see the difference in the size. Okay, both have inbuilt antenna. Okay, so what is difference basically? The ESP8266 doesn't have serial interface, means USB interface. So whenever you want to use ESP8266 directly, you have to use some USB to serial converter, or you have to use Arduino or some other hardware like 8051 or MSP430, and then you can connect it. Whereas Node MCU, directly you can connect via USB cable. This USB cable is there like this, and then this USB connector is there. You just connect the USB cable to your system, and this is available for interfacing. And it has many IO pins, so you can connect many sensors and many relays also. whereas ESP8266 only have 2 I/O pins, so you can connect only 1 or 2 sensors or 1 or 2 relays. So that is the difference main between a node MCU and ESP8266, but both are same chip, same hardware, only the boards are different. So let us understand a little bit more about this ESP8266 chip. So this is most commonly used internet module. Apart from this, a few more chips are there, like MSP430. MS430 doesn't have internet, but Texas Instrument is having one chip called CC3200 that has Wi-Fi. Raspberry Pi has Wi-Fi. Okay, so like that, many chips have Wi-Fi module, but most famous and most cheap and low cost and easily available is ESP8266. So it is a Chinese company, Espressif, which has made this chip. Okay, so what is this chip basically? It is a highly integrated chip which contains a Wi-Fi networking solution on the chip itself, along with the CPU, along with RAM, and along with the flash memory. So all this comes under one single package. Okay, so and it is having some GPIO also, with again, as I told you last time also, with again interface to SPI, I2C, and UART. So with minimum PCB area and inbuilt antenna, okay, it is having this RF transmitter receiver also, that is called your RF circuitry. It is having networking circuitry, full TCP/IP stack, full TCP/IP protocol is built into this chip. So that kind of powerful chip it is in that kind of cost. Okay, if you see this ESP module, ESP01 module, so ESP32 node MCU, like that, different type of modules are there. So if you see this ESP module here today, let me use the pointer. Okay, this is the chip, this is the main chip, and this is the memory, flash memory. Okay, your ROM, EEPROM kind of thing. So what we have is basically external flash memory you are using to store code and TCP/IP stack and other things, and it will be booted from here. So this is 32-bit CPU, and it is having 64 KB RAM, 96 KB of data RAM. Okay, external memory up to 4 MB you can connect, and IEEE 802 is a networking protocol. In that, G is your Wi-Fi protocol. So this kind of protocol it supports, which is working at 2.4 gigahertz. All your Wi-Fi modem, all your Bluetooth also at working at 2.4 gigahertz. Your Wi-Fi also is 2.4 gigahertz internet connectivity. So it is having 16 GPIO facility, and it contains SPI, I2C, I2S, and UART, all the serial interface. Along with that, 10-bit ADC also. So this is a feature of ESP8266 chip. So this is chip only this much. Okay, but when we talk about this much bit thing, it is a module. Okay, the module is ESP01. It is having integrated antenna. It is having TXRX LED status, and some people will, instead of 4 MB, they will use 1 MB flash, which is enough for our application. So you can see the pin structure now: VCC and ground, 3.3 volt and ground. TXRX for communication to Arduino or any of the microcontroller. 2 GPIOs are there, and one recent and one power down. So power down will be connected to VCC always. Reset can be kept open, so whenever you want to reset, you can use this. And TXRX only is very important pin. Using this only you can communicate with the chip via AT command. Yesterday also we have seen AT command. Today also we will see AT command, but this will be different for specific to ESP8266. This is block diagram of the ESP block. So the blue color things which you are seeing is the RF part, and light yellow color is your digital baseband, and orange color kind of thing or dark yellow kind of thing is the interface. So with the flash memory here, okay, and you can have so many interfaces. UART we are going to use today. Okay, then it has I2C, PWM, ADC, everything. Then there is a MAC layer in which your TCP/IP stack is sitting. Okay, here only your CPU, sequencer, oscillator, registers, everything is there, and your TCP/IP protocol also is implemented here. Then you got baseband here. All your modulation, demodulation will happen here. Okay, and this is the RF part, your analog transmission, analog reception. This is your local oscillator, mixture, PLL, all RF switch, everything is happening here. Single antenna is there for transmit and receive both. So these are the few AT commands which is very much important. This is the most important slide of today's theory. Okay, so first command is AT. If you give AT, chip should respond okay. That means chip is okay, chip is alive, chip has power. AT plus reset, you want to reset the chip. AT plus CW mode, you want to connect to this via Wi-Fi gateway, or this itself is a Wi-Fi gateway. That means you are access point or you want to connect access point. So if you are confused, just go for mode 3. Otherwise, you can go for client mode or access point mode. Join access point, next command. Next command, CW, join access point. Okay, now CW join access point means you have to give password and username. Now here only problem comes. Here your password will be visible as plain text and your username also will be visible as a plain text. So this command is very important command. If you are not masking it, if you are not putting it in secure way, then anybody can get your password very easily. Next comes SIP start command. SIP start is basically starting the communication with any website. Okay, suppose you want to connect to Google. So what port you want to use? What type of connection? TCP or UDP? What is the address like www.google.com or thinkfit.com? So SIP start is the starting of IP or TCP IP communication layer. Then SIP send. After you start the connection, you want to send some data. Maybe you want to search how to buy ESP266. So that is your search thing. You are sending that thing to Google website. So how to send data? How much length of data you are sending? So all these things you have to tell. SIP mux is for multiple connections. SIP start example. SIP send example. If you want to see. So SIP start first is TCP, then website name, then port number. SIP send, I am going to send it channel number 0, 85 bytes, and what are the bytes? 𝐕ET/UPADT ? API_key is equal to the key, then field of data, then CRLF. After every AT command, you have to send CRLF. Carriage return line feed. This is the structure of AT command. Okay, so maybe now I hope you might have understood the practical means the hardware of IoT and the theory of IoT and its applications. Now we are ready to do some demo on the IoT. Together with class, we will start a new demo on the IoT. So what we can do is okay. So everybody can start this website called thinkspeak.com, and then you can make your own login here, sign up here. So I have already one account. I can show you that I have got 3 channels of data. Okay, so maybe I can delete one by one channel. So this is see, like this data will be visible in various channels. I'll go to channel settings and then I'll delete the channel. Clear channel option is there, delete channel is also there. What will happen between clear channel and delete channel? So this is public view, which public can see. Okay, now this data is available of IoT healthcare. Okay, some I created in June 26, 2021. Okay, now what I'll do is I'll clear it. So I'll just share it to people first. So I'll put in chat so you can see various channels, how they look like. I'm putting in chat all these channels, then I'll clear it and delete it. So again, I'll go to my channels, smart plant, public view. So different type of widgets are there in different channels. So we'll learn today how to create all this type of widgets also. Second channel also I've given, and then third channel. So I have to go to public view. Public view is the channel number which I can send to all people, and all people without changing, without anything, without deleting, they can see. Deleting, adding only I can do because I have the private key. So there's a key concept, API key, if you see. There is a key to write. So this, using this key only I can write. A key to read, using this key only I can read. So without this key, nobody can touch my channel or read my channel. View is okay. Reading is different. Reading means you have automatic reading. Okay. Now what we'll do is at least one or two channels I can delete. This I can delete. I will go to, okay, this is smart plant. I'll delete this healthcare IoT. Okay. So channel settings. Okay. First I will show you clear channel. Okay. If I do clear, what will happen? Public view, if you go, all data is 0 now. Nothing is available. And then I go to channel settings, and if I click on delete and click OK, channel is just now out of 3, now only 1 is left out. Now this also, suppose we want to delete, we can delete it. Go to channel settings and then go here and delete. Okay. So now we'll understand step by step how to create a new channel. So I hope people might have signed up and generated login ID password for thingspeak.com. thingspeak.com. Again, I'll share the link. If somebody is pending, they can do it. Please log in and generate sign up. Okay. Now we'll create a new channel. New channel. Okay. So today this is their IET CUK healthcare. I'll put healthcare name. Okay. Or many things, smart environment or anything like that. Okay. Smart environment. Okay. Description: IEEE IoT workshop demo for smart environment project. Okay. Okay. Field 1, what I want in field 1? I want humidity. Field 2, I want temperature. Field 3, I want CO2 level. Okay, and field 4, I want maybe some other guess I can tell, or pressure I can tell. Okay. Pressure I can tell. Okay. So these 4 parameters we are going to send. Okay. Tags we can put IoT / comma IEEE comma Arora comma CUK. Okay. External site, no link, nothing. Show channel location not required. Show status. So all these things we can skip, not required. Only things were field 1, field 2, field 3, field 4. So that already we have filled properly. Okay. Now save channel. So now we got this channel. Okay. And this is the description of the channel here. These are the keywords which people can search the channel. Okay. Now I got private view, which I only can view. I only see. Then I got public view. This channel is not public. I have to make it public. So I have to go to channel setting. Okay, sharing, and then share channel view with everyone. Okay. Now I can go to public view. Now it will come. So I will share this new channel which just now we created with everybody in the chat window. Our channel. This is our channel now. But here data is not there. Any graph, humidity, temperature, CO2 level, pressure, nothing is there. It's empty. So what we have to do? We have to send data, correct? How to send data? So we have an API key. This is the key using which I can write data. So, and this is the data path. Okay. So as we know, our data is like this. First humidity, temperature, CO2 level and pressure. Okay. So first is humidity. Humidity I'll put 85. Then comma FIELD. 1 second. You can put here this password. Okay, somewhere here we can keep today's date. We can keep today is 3 OCT 21 03 OCT 21. Okay, and this is our channel. And then we want field 1 ampersand FIELD, field 2 equal to, field 2 is temperature, field 1 is humidity. So humidity 85, temperature 25. Then we got field 3. Field 3 was CO2 level. Okay, CO2 level is measured in what kind of measurement? ppm maybe. So maybe we'll see CO2 level in Bangalore. So CO2 level in Bangalore is 590 ppm. Okay. So between 5 am to 7 am, carbon dioxide levels shoot up to 590 ppm. Well, other levels found in non-polluted atmosphere 280 ppm. Okay. So let it be like around 300 ppm. And then last is your field 4, which is pressure. So atmospheric pressure in Bangalore. Bangalore is at very height. So it is around 229 Hg level. Now if you see atmospheric pressure in Goa, which is at sea level. So here 75 Hg. Okay, and this is our pressure is little lower. Okay, so we'll put around 50 pressure in Hg. Now this is ready. The string is ready. So what I'll do is the string I will put here. Okay, so things pick with my key, field 1, field 2, field 3, field 4, and then give enter. So this one came. I have highlighted this one here. One data updated to site. So the 1 dot will come. 1 dot, 1 dot, 1 dot, 1 dot. Now again I'll copy. I'll change pressure. I'll make it 55. And this pollution level I increase. Temperature also a little bit increase. And humidity a little bit decrease. So with this new data, enter. Now 2 has come. Means 2 data updated to website. So now you can see 2 dots should come. See, second dot has come. Now 2 lines have joined. 2 dots. With time, at what time the site was updated, that also is coming. Now what we'll do is I'll give in chat window the format of data to you people. So you can also send data to this website and check how it is changing in the channel. So first link is channel link. Second link is you copy the link into address bar, change the values, and you can update the values. Now I can make it 45 here, suppose, and this pollution I am increasing to 550, temperature I am increasing to 30, and humidity I am decreasing to 75. Enter. So okay, 0 has come means no success. Maybe site was busy. Again 0 has come. Why? Maybe site is busy. 4. So 4 data upgraded. What will happen when 2-3 people together sometimes sending, it may clash. So that kind of thing. So you see now. Okay. So I have increased that pollution here. Pressure decreased. Okay. and then like this, the 4 samples of data has been put into website. Now what we can do, we can add visualization. We can click here. Okay, we can go to add visualization here. Okay, add this widgets. I can add widgets. I can add a numeric display, gauge. I can add a gauge for which field. Here I can add for humidity temperature field, temperature. So minimum temperature will be around 15 degree, maximum will be around 50 degree. Okay, and at 5, update interval 5 seconds, or minimum is 15 seconds only. Okay, tick interval 5, that would be, and when the temperature is more than 35 degree, it is hot. So 35 to 50 will be red. So this is the range I have given for red. 15 is the minimum. Okay, make it 10 minimum, and make it 55 maximum, and this will be 55. Okay, now create. So now I have created a widget. So whenever temperature is high, it will show like this, red. Here current temperature is 27, so value is given here below. This is one type of widget. I'll add one more widget like a numeric display. Maybe for our last field is pressure. Okay, this is basically, it is in Hg level. Okay, so our display is created here. So Hg, this much is the pressure. Mercury level, Hg is mercury, and I'll add one more display, lamp indicator. So whenever your pollution level is high, pollution level, which is field number 3, is greater than, maybe is greater than 500, then its color will be red. We can make it red. Okay, update interval, minimum update interval is 15 seconds, and I'll create a widget. So currently it is not red, so we are safe because pollution level is around 350. Now one of you can send pollution level more than 500. So we can see they can change the field number 4. Sorry, field number 3. Field number 3 is CO2 level. Please change the field level 3 for more than 500 value and send data. Then we can see this red light will become on. In this link here, change the value 550 or something like that, 600, whatever you want. Some of you can change the values and update data so that it becomes an interactive session. I want you people to send data. I can send easily. I can just click enter, it will go. I have already value 550 set. Okay, let me send 501. Zero is coming means that is site is not updated. If it is coming 0 here, site is not updated. 9 has come means 9 bytes have been, 9 different data sets has been updated. So I have put 501 I have put just now. This has become red here. Okay, so that way we can see that how this widgets will work and how our visualization will work. So this is channel. I'm copying the channel again. Those who have missed to see the channel, they can see the channel here, and just which data I have sent, I will share that also. So you can see the channel in which data will be visible, and this is the link where data can be set. So 2 links I have sent just now. So all of you can use this link to update. Now what I want from you people also, whenever you are free, you also make your own channels like this, and you can send into your groups. Okay, so they can see what kind of data you have created, what type of site you have created. This you have created just now within half an hour. So somebody has sent this data here. So you can copy paste this. Basically, you can copy paste this like this, and after copying, and you can copy into the address bar like this, paste like this, and change the values you want to change. Okay, and then maybe different values, you can see how things are happening. So 11 bytes, 11 data has been updated. So we can see in our website 11 data has been updated. Now LED is off. Okay, and I have increased the pressure. I have increased the humidity, decreased the temperature. Okay. Now we were sending using web browser. I am using here Chrome and sending, correct? I want to send using hardware, not via a web browser. It should go via hardware like this, correct? It should go via a chip. It should go via hardware, correct? I want a hardware to be used and send data to ThinkSpeak. So that will do now. Okay. So let me connect the hardware. Okay. So I've connected the hardware. Now our favorite tool will open, which is 𝐈𝐄𝐄𝐿. You can use Putty, you can use many other software, Serial Terminal, Teraterm, so many are there. So 115200 COM4 open, not opening, COM5 not opening. I'm not sure which COM port is connected. So what I have to do, I have to go to device manager. Go to COM port and see here COM3. It is COM3. Okay, so I'll go to COM3, open. Then first try, always try AT command. First try only AT command, blank AT command, just plain AT command. No, it's not coming back. No, that means this is different COM port. Again, switch off, switch on. COM4, yeah, it was COM4, Wi-Fi connected. You can see this is boot up message is coming, got IP. This is coming like this, Wi-Fi connected, got IP, because already I have connected once. That's why it is coming. Now if I send AT command, see AT OK has come. So pink is what I am sending, black is what they are echoing back, and OK is the response. So how many times I send AT, that many time OK will come. Okay. So next command is what? Just a second. Let me copy this string. This will be useful. So let me copy it, then paste it. Then I need more details about my website. What are the more details? I want API keys. Okay, this is the API key, and this is public view. Okay. Now 11 entries are there. You can see here 11 entries are there. Now we will send one entry using our hardware. Okay. Before that, we have to learn few more things, few commands. Okay. So let us understand the command AT plus. From our website, our slides, we'll see the commands which we have learned today. Go to this slide. List access point. One command is there. List access point. One is called join access point. One is called list access point. So before going to list access point, we should be in a proper mode. So we'll go to CW mode 3. OK has come. Then I'll go for list access point. So what is the command? LAP. LAP means list access points. So nearby my home, how many Wi-Fi's are available? So one is Arora available with this much signal strength, and this is the MAC address. Again, let me type. Okay. Generally, multiple will come, 3-4 Wi-Fi's will come. Then you have to choose yours. Okay. So currently today only one is there. Okay. So what I'll do is, what is the next command is join access point. Join access point command will give. Okay. List access point. Let me try one more time. Okay. See. Now multiples have come. So I have nearby one Rakshit, one Tikona, one Arora. Okay. So like that multiples are there. Okay. Now next command is join access point. Okay. Control V. So what is the username? Aurora. Now password I have to tell you here. So this is called plain text protocol. So this kind of protocols are very harmful. 111 1 1 1 1 2 3 4 5 1 2 3 4 5. I forgot. Let's see what it is. Wi-Fi disconnect. Wi-Fi disconnected because its SIM password is not correct. Fail. Okay. I change, I think 1 2 3 4 5 1 2 3 4 5. Okay, this was the next. Wi-Fi connected. So this password is correct and got IP. So now I am connected. Oh, how I can? This is says I can connected. Okay, I connected to modem, but I connected to internet or not? How I can tell? So simple. You can do ping 80 plus C. Ping sometimes is disabled by many websites, but okay, we can always try. Okay, so let me try to ping. Yeah, response is coming. This lower the number, faster your internet. So ping to Google is working. So internet is connected to Google. So okay, maybe I can add this command here, and I can add this command also here. Okay. Okay, next is what? So pinging is over. Next is you want to start a communication to the website, correct? So we are going to communicate with this fellow. Okay, but only thing is I have to count the characters, how many I have to send. Before sending to internet, you should know how many characters you are going to send. Okay, so mux is there. So these two things I'll copy, Control C, and then I'll paste it here, Control V. Okay. So we have to create new command set, new data set. What is our new data set? Today's website which we have created. So first line, mux. Okay, one channel I'm creating between me and TCP/IP of ThingSpeak. Next is connect to ThingSpeak. Protocol is TCP/IP. Website name is thingspeak.com and port number is 80. This 80 is port number. Then zip send 95 bytes. That may not be correct, so I'll delete this line now. Okay, this line I am deleting, and I'm going to copy this line here, and then the command. Command is get and put. These two are the commands using which we are sending the data to website. Get command and put command are the commands to send to data to any website, TCP/IP website. Okay. Now at the end we need CRLF also. Every command should end with CRLF. Okay, now how many bytes? This is basically 77 bytes plus 2 extra bytes for CRLF. So 77 plus 2, it will become 79. You understood the 79 how it came? Again, from get 245, this is basically 77 you have selected bytes. Okay. See, for example, get is only 3 bytes. So how much is coming? Selected 3. Okay. Up to 45 is coming, selected 77. At the bottom line you can see. And then plus 2 extra bytes for CRLF, so 79. So 1, 2, 3, 4 commands if I send, followed by SIP close, I should be able to send data to ThinkSpeak. So Control C. Okay, where is that Hercules? Control V, Control C, Control V, Control C, Control. Why I'm doing like this? Because I should send fast. Between if too much gap comes, then problem. So mux command, OK has come. SIP start, error has come. It's not connecting. It's not starting. Okay. Let me check. Okay, sometimes this extra 0 is required. We'll update this place here. Okay. Channel we are telling there only. Okay. So, and then here 0. Okay. So I updated here. Now we'll go here back and then copy this. Now we'll again try to start, SIP start. DNS failed because I am trying to start with the SparkFun. Website name is wrong. It is TCP API address. Okay, again I'll try SIP start, connected. Okay. Now SIP send. SIP send. The arrow key has come, means data it is accepting. Control V, send. 79 bytes received, and this is the reply. Okay. Now I have sent some data. 501 data I have sent with 45 pressure, 30 temperature, and 75 is. This is the last data should be there. Okay. We'll go to our website and see, after so much of delay, on 75 data has come, correct, with pressure 45 and temperature 501. So this last data has come from actually hardware. Again, this 501 I'll make it 601, 45 I'll make it 55, 30 I'll make it 40, and 75 I'll make it 95. So again we'll try. Start connection, SIP send 79 bytes. Send the data. I got connection OK, and you can see now this new data is coming 95, 40, 55, and 601. Okay, and this is also now red. This is also in red zone because your temperature is higher, pollution level also is higher. So now data has been sent from where? Actually, it's sent from the hardware, the Esp module, which I am having here now. Okay. Using this module, we have sent the data. Using this module, now we have sent the data. So what we'll do is, now this 80 commands which we have just generated today. Okay, where is that file? Here. So this I'll delete. Okay, so this 80 commands I'll give you. A close command was not useful. Why? Already it is getting closed automatically, so I don't have to close again. Now I'll put this AT command in the chat for your reference. Okay, these are the AT commands which we have used for sending this data. And before this, we have used some more AT commands to connect to internet. So list action point, join access point, okay, ping. That also now popping in chat window. Okay. So these are the AT commands which are minimum required to communicate to any website to send data via IoT. Now what we'll do is the same thing. We'll try to write a code in Arduino. Okay, and then instead of doing with help with manually by doing with what is this called 𝐈𝐿𝐿𝐼, we'll do with Arduino automation. Okay, with this hardware. Okay. So we don't have now pressure sensor and this pollution sensor. Only I'm having this temperature and humidity sensor. This DHT11. So this other two data will make it fixed, and this data can go as a different value. So let us try to connect this Arduino. Okay, Arduino is now connected. Right. Okay. So this 80, you should always check 80 OK is coming now. Yeah, close. Now next step is to open the Arduino. Recent. I have this air pollution. Okay, file, save as. I'll just name it as smart env. Okay, smart env here. So first thing is software serial. What is the meaning of software serial? We have to understand that. As we have discussed in our previous slide, your Arduino is having only one serial port number 0, port number 0 and port number 1, RX0 and TX1. Only one port is inbuilt, which already we are connecting via USB for for computer communication and debugging. But this ESP8266 or Wi-Fi module requires one more TX-RX. So I have created a virtual TX-RX. I created one virtual TX-RX. Okay, and this virtual TX-RX will communicate to ESP8266 or Node MCU. Okay, or Node MCU. Okay, or anything, any different similar modules. So as we have seen, the password is to be changed 99999 5 times 9 and 1 2 3 4 5 5 times 1. Okay, now this air sensor, I don't have air sensors here, so I'll just comment this line. Okay, or let it be connected. Some junk values will come, let it go. Okay, some two sensors are there. Air sensor 1, 𝐴𝑠7, 𝐴𝑚Q135. These are different sensors for measuring different pollutants in air. Okay. But in this, humidity is not there. So let me get a code of humidity. This we have done that day. So this library I'll include of DHT11. Then this pin definition and object definition of DHT11 will include here. Okay. And then what we'll do here is, this is access point and password. AS sensor 2 is not required. I'll remove it. Only AS1 is enough. This also I'll just remove. Software serial is a very important object. I'm creating one object called ESP8266, one more serial port. Normally, if you remember, we'll use this serial port, default serial port, serial.begin, correct? Serial.print, serial.print, serial.println. This was our normal serial port, which communicates to USB to system. Two functions are there: connect Wi-Fi and send data. Sensor 1 data is enough for us. Sensor 2 is not there. Sensor 1 value is there. Okay. Okay. Now, serial.begin for PC communication. I write here PC communication used for debugging or understanding what is happening in system or monitoring. Okay, this is actually IoT module connection. IoT module connection via software serial, or you can say emulation. What is the meaning of emulation? See, there are three words: simulation and emulation. Simulation is if real world thing is converted into software and simulator. Emulator is real world thing, a physical thing is done by some other physical world. That's called emulation. Hardware replaced by some other hardware. So pin mode, LED pin output, LED is low, and then will be IoT base, smart environment. This is our title line. At beginning it will come one time only for IEEE. Okay, and then function will be called connect Wi-Fi. Connect Wi-Fi requires only one. Collect data, send data. Collect data, send data. That much only you do every 10 seconds. Okay. Now, what is collect data and send data? So, collect data is reading sensor value. You read the sensor value, map the sensor value. Mapping, suppose if not required, also we can ignore it. Okay. So, I'm not mapping it. Whatever is coming, simply I'll transmit. So, it will collect the sensor value. Okay, and it will try to send. But we have two more sensors here, which is your DST sensor. So what we'll do is we'll call this also read DST. Then we have variable DST humidity. So I'll define this variable HUM data is equal to string. Why I'm connecting it to a string? Because when you're sending to IoT platform, everything has to go via as a string only. So humidity data, and then temperature data is equal to again string. Okay, but variable will change, it will become temperature. Okay, so these two variables are created again here. DST read is happening here, collect data is happening here. So collect data will collect all data from the sensors, this function. I hope this function is now very much clear to you. Read analog, suppose you are connected one oh, we are having two sensors, no? I forgot. Pressure also is there. Okay. So pressure also is there. Sensor 2 value, sensor 2 data, sensor 2 value, sensor 2. Okay. So I have to enable this here somewhere. A0, A1. This is sensor 2. Okay. And we were having one more thing which we can do now. That mapping. Map function we can use here to map sensor 2 value between HG levels, because HG levels should not go random values. So we'll map it to some reasonable values. So from 0 to 1023, you make it something like 20 to 100. Okay. So this will be range. This numbers will be converted into this number, and that only will go as sensor 2 value as a string. Okay. Now what else we have to do is, okay, connect Wi-Fi function we'll understand. First AT command I'm sending. Okay. Then this is number of tries. Then I'm changing mode to mode 1, which is client mode. Then join access point with access point username and password. 20 times try not required, 5 times try will do. Okay. So this is the way my hardware will going to connect to Wi-Fi. Okay, now send data. Send data is very important here. This key has to be changed with my key. So where is my key? This is my password, my key. So this has to be replaced here. Site is same, port number is same, only key is different for different projects. Okay. Now send data. So as we know what we were doing in our code in Hercules, if you remember just now, when Hercules we were using, what was our scheme? First send SIP start, then number of bytes, then get command with update feature, API key and field numbers. So same thing we have to do here. Same thing we have to do here. Where is that code? Here. So get command, update command with API key. Then field 1 is sensor 1 data, field 2 is sensor 2 data. Then I have more na field 3, field 4, correct? Ulta. Field 1 is actually humidity in my case. So this has to be repeated again. Control V. Okay. Then okay. Now field 1 is humidity data. Field 2 is temperature data, correct? Field 3 is your sensor 1, which is nothing but pollution level. Field 3 is pollution level and field 4 is your pressure. Okay. So field 1 variable, field 2 variable, field 3 ampersand should come here. Field 3 variable, field 4 variable. Okay. Now once these data strings are ready, get 1 string and get 2 strings are ready. SIP mux 1. Okay. 2 tries are enough. Then SIP start. Okay. 3 tries are enough. And this will be your SIP send. How many bytes? So how to calculate bytes of this? Command is called dot length. So dot length command of this, then dot length command of second string, and plus 2 why? CRLF. Reply will come this one. OK reply is coming means this command is successful. In this also OK reply is coming, this command is successful. But in this last command, if you see Hercules here, it's not coming now. Okay, we can see. What was the command here? Okay, this one na. Okay, I'll show you again what we are expecting. Okay, see SIP start, open, SIP start, OK has come, SIP send, OK, and then this greater than sign has come. Then I am sending this data, correct? So this is very important, this arrow greater than sign. Okay. So when in the code I have a greater than sign, that means my command is successful. Okay. Once greater than sign comes, you please send both the data 1 and data 2. Okay. Serial.print means print on the computer. Esp.print means sending to the actual module, IoT module, the node MC module. Okay. And then SIP close. If required, you can send. Otherwise, as per new code, not required. Okay. I can comment it actually. Whatever not required, I can comment it. Okay. So what is the send command function actually does? Basically, send command function will print whatever you are sending. Serial.print, again I'm telling, it will just print computer. Nothing actually does. But esp.print actually send the command to Esp module, wait for reply. If reply is found, it will break it. If reply is not found, whatever reply you are expecting, that reply is not found, then it will retry. How many times you have given try, that many times it will retry. Okay. Sorry. Now as found is come, OK done will come. This OK done is very important. If after all the tries are over, it will come as a fail. Okay. So now this is the complete code. Now mostly we have written properly only, but we have to test it because we have copied from here and there and finally come to your final code. Okay. We'll try to now compile and dump it. Some error is there, it will come now. Compiling is going on. You can see in the downline. This compile. See some now sensor value we have not defined. Okay, sensor value. Here sensor data 1, we actually removed it, but then we added later again. So sensor 2 data, sensor value, sensor 2 value. Save, compile again. Okay, hum data was not declared in the scope. Hum data where we have defined. Okay, this hum data and temperature data we have not defined, it seems. Okay, so we'll define it here. Here, hum data, comma, temp data. Now we'll compile and upload. Compilation is successful means it will start uploading. Done uploading has come. Okay, now what is it telling? We have used 30% of program. Still so much space is available. 70% of space is available. And we have used 32% of RAM. Still 70% of RAM is available. 133 bytes we have used. 1300 bytes is available actually. Sorry. 600 bytes we have used. Okay. Now tools, serial, monitor. Now we'll see what it's trying to tell. First, it's stored in the title. AT command has failed. CW mode also has failed. Join access point. How many tries it is trying? 5 times it will try. That also has failed. SIPMUX failed. TCP IP has failed, and this also has failed. Okay. Now next cycle it will try. Why it is failing? Because I have not connected ESP module. Okay. Without ESP module, how they will communicate? So we should connect now ESP module, then only they can talk. Okay. So I need 3 wires, TX, RX, and ground. TX, RX, and ground is enough. 3 wires are enough. Okay. So one side male, one side female kind of wires are required. One, two, three. 3 wires. Okay. So what I want is one green can behave as a ground. So V in nearby is ground. Okay. Now pin number 10 is RX. Okay. Pin number 10 is RX. 1, 8, 9, 10 is RX. 11 is TX. Okay. Over. Now coming to ESP module. Green is ground. Ground is here, second pin. Green is ground. Ground to ground of both should be made common. Okay. Now first here is TX, then RX. First is TX, then RX. Okay. Okay. Connected. Now we can see in the video these 3 wires are connected to ESP module, and then 3 wires are connected to Arduino board. So just this much I have connected, not much. Okay. Now we will go back to our screen here. See, okay done is coming now. SIP send is fail, but this has come okay done. This is okay done has come in SIP send. Oh, SIP send is coming continuously fail. That 0 is not required, na? Extra. So we can remove that extra 0 from the code. Okay. This can be removed. can try. Save. Again load the program. Oh, it came. Okay, done. Sorry. Then that was required. Control Z. Save. Now it will. Again I load the program. Okay. What data is going? Field 1 and 2 are going 0, 0. This is going 435 and this is going 47. We will check in our website what is happening. Okay, so this 0, 0 has come, na? 0, 0 has gone. This 2, 0, 0 has come from the hardware, not by our hand. Okay, and this values of CO2 and this value of pressure has come again by the code only. Code means actual hardware only. Good. So this is coming 0, 0. Why? Because we have not connected DST11. So we'll connect DST11 now. So VCC ground. This pin should go to pin number 2. 0, 1, 2. Now next time onwards, this 0, 0 should not go. Okay, so 0, 0 should not go. Field 1 and field 2 should not go 0, 0. Okay. See, it is coming 55 and 25. But this has come fail. Sometimes shift send will not work, na? So you can see okay done should come. Everything okay done means your sensor data is going properly. Temperature is 0. Pollution level is low. Going back to this field, okay run has come, means this data is gone. This 5625 has gone. So 5625. So whatever data is there in the Arduino screen, Arduino COM port, same data will be also visible. 227 and some 36. So 36 you can see here. You can see in graph also here 36 and 227 is somewhere here. Okay, because we have not connected those sensors, so it is not sending the data. So I hope you have understood now how Arduino program is there to send the data. So maybe one small revision I can do of the program, how data is going. First of all, some libraries are there. Software serial, thingspeak.h and thingspeak.h is here only. DST11 for DST sensor. Then software serial we have defined a separate serial port because already our serial port is busy in PC communication. So pin number 10, 11 also we have made a serial port. Pin number 2 DST pin we are connected. Then DST module we have created here. Password and username for your Wi-Fi. This is for counting how many times you have sent the command. Number of sensors which you have connected. That pin numbers A0, A1, analog sensors. Start the software serial with name so and so, Esp8266 name with RS and so on, 10, pin number 10, pin number 11. Two functions, connect Wi-Fi and send data, the Wi-Fi module function. Whereas collect data function is a simple function which collects all this sensor data. Start serial port for PC communication. Start serial port for IoT module communication. This is LED, we are making it low initially, and our title line is there, and starting we'll connect the Wi-Fi. After connecting Wi-Fi, call function collect data, make the LED high, send data, make LED low. Means whenever LED, see when your laptop is not connected also, you'll come to know whenever LED is on, data is going. Whenever LED is off, it is in wait period. Okay. So after wait period, it will collect new data and send in new data. So collect data, read sensor 1, read sensor 2, convert them into strings. If mapping required, do mapping. If mapping not required, directly convert into string. Then read DST humidity, read DST temperature, convert into string. Because this send command function only accepts string. So connect Wi-Fi function, how it works? First try AT command, then try CW mode command, then try join access point command with password and username. This is basically reply expected. This is number of times you have to try, and this is the actual command, AT command. Send data. First make the data string which has to be sent. field 1, field 2, field 3, field 4. How many sensors you are having or how many data you are having, that many fields. Then your key is here, API key. This key, API variable is here defined. And then first start one channel connection. Then start TCP/IP connection with name TCP/IP with website name host. Host is here. Port number also is here. Then SIP send, number of bytes you calculate. How this basically is field 1, field 2. How much bytes are there? So as per me, it was 77, 79 that time. But now here this is 3-digit number and some more numbers have increased. So it is coming to 80. So we can see here also again around 85 is coming. Okay. Okay, now once you calculate number of bytes, that many bytes you call command +2 send data command, or this command SIP send command, this one. Okay, see this is a reply coming from the module. I can see this is a reply coming from the module. So whatever they are sending, I can see parallelly also here what is happening. Okay. Okay. Now once this comes, you are sending data, and then okay, then actually sending data is happening here. Send data 1, send data 2, and you are printing what data you are sending. Serial.print is for for your PC printing only. See, you can see in the PC what is getting printed. Whatever you are sending is getting printed here. Okay. And then SIP start. Okay, 2 connected, so we cannot connect it either. Okay, then what is there? Send command. Okay, send command function, what it will do basically, whatever command you are send, which is this parameter 1, how many times you have to send parameter 2, and what is the reply expected. So first there is a command counter. So 1 command, 2 command, 3 command is coming here. You can see here. See, 1, 2, 3 is coming now. So 1 command has come. Okay. Then you make it 1. Whatever command you have sent, command you show. This serial.print is only for PC, not much useful. Then actual command is going here. Once command is going, then you wait for the reply. Reply okay comes means break the chain, break the loop, come out. If reply has not come, try, keep on trying till max time is not reached. If max time reached, come out. If found equal to true is there, then okay done will come, else fail will come, and this all things are becoming 0, 0. Sorry. This was the, how many lines are there? 127 lines. Hardly 100 lines actually. 100 line of code is enough for your simple IoT project. Okay, and which can be done within 2 hours. That is the gist now. Maybe one reset we can give. Okay, so this many data you can see, this many times data has gone. Last data received 2 minutes ago. Entries, total entries 23. So all this entry from here onwards to here onwards, see just now it came one more. You can see here, okay done has come. So this last entry also was from here, just about a minute ago. Created about an hour ago, last entry about a minute ago, total entries 24. Now, one more thing which I want to show you here is, all this data I can export by clicking on data import export. So there is a button here, data import export, you click that data, okay, and you can export download data, all this data, download. Okay. Okay, so feed.tsv, save. So it got saved here. So I'm opening it. I hope you are all able to see. It will open an Excel file. See, this is the data. It is in UTC. UTC converted into ISTs, you have to add 530 in that. Okay. So field 1 85, field 2 85, field 3 300, field 4 50. In between, you can see 00 is there. Now this point onwards, 15 data onwards, everything is from the Arduino hardware. So 1102. 1102 means around 4:30. In our Indian time, it is 4:30. UTC to Indian time is 5:30. You have to add. So 5 you have to add in hour, 30 you have to add in minutes. So it becomes 5 means 16:30. 16:30 is 4:30. So this was the end of our IoT lecture and workshop. So we have completed IoT. First, what we did, we just send data using browser by sending links like this. Correct? Same link I have shared to you people also. Sorry. That window. Same link I have shared to you like this. Okay. Using this link, copying into Firefox, address bar, we have done it. Okay. We can change the values, field 1, field 2, field 3 values, and then do it. Next was use Hercules or serial software. Any serial software you can use, like Putty, Teratum, anything you can use, and using that we have done it. So that was like this mode. Okay. This command. Okay. Zip send, zip start. Okay. Like this we were doing. So we have tested our hardware. Hardware was working fine. Then we went for final thing, which was the Arduino code. Using this kind of method. Very simple main program. You can see our main program, our main loop is very small. Collect data, send data, delay. Collect data, send data, delay. That much only. Our setup program also simple. Start both the serial port, show welcome screen, welcome message, and connect to Wi-Fi. That much only. This is our void setup and void loop over. This much only. But all these functions are below, doing all the main job. Correct? I hope all of you have pretty much understood, at least basic level, that how a IoT program can be created, in which you can send a particular sensor. Like in our case, we have used DHT11 actual sensor and send to internet using a Wi-Fi module and Arduino. Correct? Two hardware. I'll stop presenting. Now, Akhila, if anybody is having questions, they can take questions.
Okay. Anybody having doubts, please feel free to ask.
If somebody has created their own page of ThinkSpeak, they can share their channel like this. So public view, you can click on public view, and then you will get channel number, and that channel you can share. Where is that? Where is that? Here. Yeah, like this. This is our channel number which we have created. Like this, if somebody else has created, they can share their own channel number. And if they want, we also should be able to edit their channel, send data to their channel. Then they can share a link like this, a second link for editing purpose. This is above is for only view. Only view. Next link is for updating to. Okay. Because it contains API key, that password, and then field 1, field 2, field 3, field 4. So field 1 was humidity, field 2 was temperature, field 3 was pollution level, and field 4 was pressure level. So in chat you can give feedback also. How was the lecture? What improvement we can do in this kind of lecture? Because this kind of lectures are pretty physical lectures. Online we are attempting to do, but how much successful we are doing, you will get feedback from you people only. So once pandemic things are over, little things are normal, maybe we can come to your place and do one more time from IEEE.
Yes. I have posted the feedback form link in the chat box. Please
Okay.
everyone go to the link and
Yes.
fill the feedback.
You share the feedback with me also, Akila, once they are given.
Okay, sir.
Yeah. And yesterday, who was there? Bhargav was there, na?
Yes, sir.
So yesterday and today feedback they will give together only. So okay, you can share that feedback. Rashi is there today?
No, sir.
Okay.
Yes, sir. Sure.
She is also there. Okay, okay. Because she
Yes.
only has invited me. Okay, thank you, Rashi. Thank you very much for inviting me for this 2-day workshop. I hope Arduino basics we have covered with sensors also, and then we have covered today IoT, how to create a web page in IoT, then how to send data using Hercules or just a serial software, and then actually using the Arduino, how to send the data. Step by step we have gone, and we have shared multiple links with students in which they can also participate in sending the data to the cloud, and ThingSpeak Cloud was used today, and I hope most of the students have understood how this ThingSpeak Cloud is working, and we have used a method called get method to send data to cloud. So I hope today's lecture was a little informative to our students, and they can use this knowledge for their startups, their projects, and their internships. Thank you very much. Thank you to all.
Thank you
Okay.
so much, sir. Over to you, Akhila.
Okay. Okay, thank you, sir. I request our branch counselor, Dr. Santosha Kumar, sir, to give vote of thanks. So, Santosha Kumar, sir, please give vote of thanks.
Meanwhile, students can see how our site is reacting. Around 39 entries have become. So only first 15 entries were manual. Now,
Yeah, good afternoon.
good afternoon, sir. Hello, sir. How are you?
On behalf of yes, sir, yes, sir. Yeah. I hope all of you have got the basics of IoT and you can work on your projects in coming semesters or for your projects. Thank you, sir. Thank you for sharing your valuable time and knowledge with us. Thank you, sir.
Thanks. Maybe students are waiting now for maybe day to end. It's a weekend for them, and they may be looking for some relaxation on this weekend. So it was a great interaction with students and Akhila, Bhargav, and Rashi. And Santosh Kumar sir, thank you for this opportunity for this workshop. I hope the students will be using this knowledge for all these projects. We have shared the link also in chat window. I'll share one more time. Maybe if sir is having some time, he can also see what we have done today in this link. All data is available.
Yes, sir. Thank you. We would like to present a small token of appreciation for you, sir.
Thank you.
Thank you,
Akhila.
sir, for your informative session. I hope all of the participants have received a lot of knowledge from you, sir. Thank you. Thanks a lot.
Thank you. Okay. Have a nice weekend. Guys, you can keep in touch. So anyway, I've shared my details to you at the beginning, and my details are there with most of your faculties and course coordinators, because being in IEEE, we always have a good network. So thank you very much. Have a great day. Have a great weekend. Bye. Take care. Keep safe.
Yeah, thank you, everybody. Please fill the feedback form and just leave them. Thank you. Okay, sir.